We're all always excited about space missions and their discoveries. It is impossible to forget about both Voyagers when we speak about this. The American Voyager program uses two robotic probes, Voyager 1 and Voyager 2, which were launched in 1977, to make astounding discoveries concerning a variety of cosmic wonders. Welcome to Space Getaway. Here you will find all the latest and exciting space news. Do you think 46 years is such a long time? Let's see what all news we have from Voyager 2 when it traveled for 46 years. NASA launched the unmanned spacecraft Voyager 2 on August 20th, 1977. Its primary mission was to conduct close flybys of Jupiter, Saturn, Uranus, and Neptune, known as the Grand Tour of the Outer Planets. The spacecraft on NASA's mission to study the outer planets and other heavenly bodies are managed by the Jet Propulsion Laboratory in Southern California. The Voyagers initially targeted just Jupiter and Saturn, but Voyager 2 went on to study Uranus and Neptune as well. This was accomplished by taking advantage of a rare planetary alignment to use the gravity of one planet to redirect the spaceship to the next. To perform their in-depth investigations of the outer planets, the Voyagers were equipped with cutting-edge instruments. Both spacecraft are still sending data back as they leave the solar system and head towards interstellar space. The next alignment of the outer planets, which happens only once every 175 years, would take place in the late 1970s, according to mission designers at JPL in the 1960s. With enough technological advancement, spacecraft may leverage this once-in-a-lifetime alignment to fly by Jupiter, use its gravity to deflect them into Saturn, and then repeat the procedure to travel to Uranus, Neptune, and Pluto. To visit each planet separately would require launching multiple missions, which would take much longer and cost much more. The 1971 cancellation followed the original proposal to deploy two pairs of thermoelectric outer planet spacecraft on these grand tours, being found to be prohibitively expensive. NASA Administrator James C. Fletcher announced on March 7, 1977, that the Mariner Jupiter-Saturn 1977 spacecraft would now be known as Voyager 1 and 2. One of them might eventually travel to Uranus and Neptune, accomplishing the majority of the original Grand Tour's goals, scientists hoped. Many more years would pass before Pluto received its first visit. Jupiter. 15 days before Voyager 1, Voyager 2 was launched from Cape Canaveral in Florida. Voyager 2 traveled farther and more slowly than its twin, and it reached Jupiter in July 1979, 2 years after its launch. Its journey's Jupiter chapter went deeper than Pioneer had in its exploration of the gas giant, its magnetosphere, and its moons. Amazing views of the entire Jovian system were returned by Voyager 2, and the time-lapse movies created from its images of Jupiter demonstrated how the planet had changed since Voyager 1's visit. The Great Red Spot was closely examined by the spacecraft, which discovered that the storm steadily diminished over time. Io's surface has changed over time, and its volcanic outbursts have persisted, as seen in the photographs. Additionally, it showed a third element of the planet's rings and the existence of the 14th moon. It traveled towards Saturn, utilizing Jupiter as a launch pad after studying Jupiter using the gravity assist method. Saturn. On August 25, 1982, Voyager 2 reached the charming planet Saturn with its rings. As a result, after Pioneer 11 in 1979 and its twin Voyager 1 in 1980, it was the third spacecraft to visit Saturn. Another up-close look at Saturn and its moons was provided by Voyager 2. The spacecraft observed the planet's rings with its photopolarimeter at a considerably higher resolution, which resulted in the finding of many more ringlets. Additionally, it gave clearer pictures of the shepherding moons, the F-ring, and its spokes and kinks. It used a gravity assist maneuver at Saturn to help it get to Uranus after finishing its circuit of Saturn. Uranus. Voyager 2 reached its never-visited-before target of Uranus in January 1986. It was the first spacecraft to ever visit Uranus as a result, and it is still the only one to have passed by the planet. The probe discovered evidence of a sea of boiling water roughly 800 kilometers beneath Jupiter's cloud tops on its journey there. Additionally, it was discovered that the average temperature at its sun-facing pole was the same as the equator. 10 new moons, 2 new rings, and an oddly slanted magnetic field on Uranus that was stronger than Saturn were also found. The planet is 98 degrees inclined, which means it essentially turns on its side, as observed by the probe. Following its exploration of Uranus, the spacecraft was propelled toward Neptune by a gravity assist at Uranus. Why do you think Voyager 2 followed a map by the NASA scientists on the space? Guess what? Even it didn't want to get lost in the tilted axis of Uranus. All joking aside, do like the video, subscribe to the channel, and press the bell icon for notifications. Let's go back now. Neptune. Voyager 2 reached Neptune on August 25, 1989, about 3.5 years after it left Earth for Uranus. It is the only artificial object to have flown by Neptune so far. The spacecraft traveled less than 3,100 miles above the planet's cloud tops during its closest approach of the whole trip. Voyager 2 made several discoveries about Neptune, including 5 moons, 4 rings, and a great dark spot that had disappeared by the time the Hubble Space Telescope captured an image of the planet 5 years later. Additionally, it showed that Triton, the biggest moon of Neptune, is the solar system's coldest known planetary body and has a nitrogen ice volcano on its surface. Voyager 2 started its interstellar mission extension after its Neptune reconnaissance, which is still going today. The imaging system of the spacecraft was first shut off in 1998 to save power. Despite this, the spacecraft has continued to collect data on cosmic rays and the solar wind. Voyager 2 passed the heliopause on November 5, 2018, 6 years after its twin, which marks the transition from the heliosphere, the bubble-like area of space produced by the Sun, to the interstellar medium. More than 12 billion miles away from Earth, where Voyager 2 is currently operating, it takes 18 hours for a signal from the spacecraft to reach Earth and the same amount of time for a signal to return. Up until roughly 2025, according to engineers, Voyager 2 will keep sending back data. Additionally, like its twin, Voyager 2 carries a gold-plated record that includes information on its home planet, as well as recordings of music, greetings in 55 different languages, and sounds of the terrestrial environment, just in case an extraterrestrial intelligence finds it one day. Instructions on how to play the record were carefully added by NASA engineers. After its sister ship Voyager 1 did so in 2012, Voyager 2 became the second spacecraft to do so. Voyager 2 is still transmitting data from its 5 active instruments as it navigates through interstellar space as of July 2019. Additionally, it is anticipated that at least one of the spacecraft's instruments will continue to function until 2025. But regrettably, there will come a moment when there won't be enough power to run even one experiment on the spaceship. Voyager 2 will continue its silent, unending voyage across the stars in this manner. It will be nearly 40,000 years before it approaches another star. So that's all for today. Can any other space mission provide information like Voyager 2? What's your opinion on this? Do let us know in the comments section.